UI image view is the class name, and 2 labels. And if I actually click on these things, we can see how they're configured. Let me click on the ball in the middle there. It's 10 pixels by 10 pixels, according to what I made in Photoshop. And it's indeed a UI image view whose image source has been specified to be that ping in question, just like we did with the rob.ping earlier. Same deal for the others, and score left and score right, if we go to the identity inspector, is indeed a UI label. So in this case, what I literally did in advance was I dragged and dropped 3 UI image views from the palette of options down there. Then I configured them, just like we did with Rob earlier, to be ball.ping or paddle.ping, so as to lay that out. And then the scores, I just manually typed. Previously, they just said label, and they could still say label. I just thought it was a little more instructive to give them left and right names. That's all. All right, so now if we go to viewcontroller.m, here's where all the interesting stuff must be happening. So first, I decided, just to make it easy to tinker with my game, to declare a velocity constant at the top of the file, initialized to 10.0 in a floating point value. So this is like the speed, 10 points per second or some unit of time. And then I have inside of my nameless category a CG point velocity. So somewhere in this class, I need to keep track of what is my current velocity. Because a velocity, recall, is essentially a vector telling me how fast to go up to straight up, or to the right, or the opposite thereof. So it's some kind of speed, a change in rate, dy dx. So I need to store my current one so I know at every second of the game how fast should the ball be moving. Now I have a whole bunch of private properties here, but most of them are as expected. I've got IB outlets for all 3 of the UI image views that we saw earlier, and I've got 2 IB outlets for the UI labels that we dragged and dropped. So that leaves a few here. NSU integer, what might that mean? Yeah, so it's an unsigned integer. Why? I figured the score never needs to go negative. So just to be proper, I'm going to specify that it's an unsigned, that is non-zero integer. I could have just done little u unsigned int, but just to be consistent with iOS practices, I gave it the NSU integer, which is just it's not a class, it's just a type def. It's a synonym for unsigned int. All right, I've got one for the left, one for the right, and bool for paused. I needed some variable just to keep track of whether or not the game is paused. And when does it seem to pause, based on our tinkering earlier? What's that? When it's in the background, and also in the beginning, when the ball is just sitting there in the middle before I actually start interacting with the app, or conversely, every time there's a score made, then the ball goes back to the center and I have to touch it for the game to resume. All right, so now in the view controller, a lot of this now is just logic. So after initializing the object with the nib name, I'm initializing the score left and right to 0. I'm first declaring a velocity. So a velocity has to do with motion, and yet you can represent it with a point. If a point is just x comma y, you can just treat the x as delta x and the y as delta y, change in x, change in y. So I just use the now familiar CG point make, velocity comma velocity, and this just means if it's 10.0, what did we say it was earlier, the constant? 10.0, this just means for every unit of time, move 10 points this way, 10 points that way, effectively going on a straight diagonal. All right, so what happens next in this initializer? This is how the game actually has motion. So we declare what's called an NS timer. We schedule it with a time interval of 0.05. So every 5/100ths of a second, I want something to happen. And I just decided on that by trial and error to see what would feel right. Targeting myself with a selector of play. So apparently, I want what method to get called every 0.05 seconds? The play method. All right, and beyond that, and it repeats in that if you recall from JavaScript, there's set interval and there's set timeout. This is like set interval, given that I'm passing in repeats a value of yes. So now what happens next? Nothing seems to happen there by default. Let me scroll down. There's a play method. A lot of math there. Touches move. So touches began. So it looks like what I'm doing here is when there's a touch on the screen, I'm changing the value of paused to no. So this was my way of kickstarting the game. As soon as touches begin on the screen, doesn't matter where the human touches, that means kick the ball. Let's start the game of Pong playing. And I change that Boolean field. So presumably, my play method is going to check that value. So let's go into play here. And indeed, if the game is paused, just return immediately. Don't play anything. Don't do any mouse movements or cursor movements or ball or paddle movements. Otherwise, move the ball. So this is very similar behavior to before. Even though this is being called on a timer, not in response to user action, what do I want to do every unit of time? I want to move the ball how? Using its velocity. So if its velocity is 10, 10, every time the clock fires, I want to move it over 10 and up 10, if that's its current velocity. And that's what I'm doing. I'm making a new point, taking the ball's current x location, adding the velocity's x value, then comma, the ball's current y location, and adding the velocity's y value. But now I have to somehow detect when the ball is in the goals, as was proposed earlier. So what is this line of code saying? If self.ball.center.x less than 5. What's the implication of that logically?
Position with respect to a certain boundary, that it pretty much knows that it's some sort of desired threshold.
Exactly. So recall that 0, 0 is the top left-hand corner. So if the ball goes within 5 pixels of 0, it's really all the way over to the left, at which point I'm just going to say that's a goal. It went over the boundary. So who should get the score? The guy on the right. So score right should be plus plus, because he's the one who would have kicked it into that end. And then I call self kickoff. Well, what does kickoff do? Let's come back to this function and this method in just a moment. Kickoff does a few things. It pauses the game, apparently. It then updates the scores based on what's in the NSU integer. So the unsigned integers are numbers, but I want to turn them into strings so that I can paint them on the screen in terms of those labels. So that's using some building blocks from a few weeks ago. Now I want to center the ball, and I'm going to go ahead and center this at that particular location here. And then I'm going to go ahead and align the paddles, which was just a bit of trial and error, figuring out exactly what made sense on the screen. And now if I scroll back to play, what happens otherwise if there's no goal on the left or on the right? Well, bouncing is kind of an interesting thing. So what is this if condition handling? The highlighted lines are doing what and how? Yeah?
All it's saying is if it hits the top or bottom, all you need to do is switch the direction of the y part of the velocity.
OK, good. So as the comment says, this has to do with bouncing off the top and bottom. But how? Well, if the y coordinate of the ball center is less than 5, that means it's really close to the top. And if its velocity at that point is some value, how do you make it stop going upward? I'll just change the velocity to negative. So if we effectively want to make right angles when we hit the side of the wall, it actually suffices. If, again, you think of the motion as an x component and a y component, if the ball is going up this way, you don't want to change the x motion. Like, you don't want it to go this way, because that would be weird if the ball hit here and then went this way. You want the ball to go this way and keep going to the right, but you want it to start coming down. So all you have to do is flip the y from positive to negative, or conversely negative to positive, and that's exactly what we're doing inside of this if condition. If we get within 5 pixels of the top of that screen, go ahead and flip the y's velocity, as with that negation there in that line of code. And the or is just handling the bottom of the wall as well. And the fact that I'm using a negative sign here means it doesn't matter if the ball is going up, now it'll come down, or if it's going down, now it's going to go up. The left paddle is a little more interesting. And how are we apparently detecting intersection? Well, it turns out in the core graphics library, there's a helper function called cgRect_rect, and you can pass in 2 rectangles, and it will return true if they're overlapping, which is perfect. And this is why I didn't quite make the ball a circle. I decided it'd be easier to just make it a 10 by 10 square. So this way, no matter where it touches, it's sort of geometrically reasonable to assume that it's going to bounce. And so in this case, if the frame intersects, the frame of the ball intersects the frame of the paddle, then go ahead and inverse the velocity from negative to positive or positive to negative, depending on which paddle you have just hit, if you're on the left or you're on the right. Yeah?
If you would increase the velocity of the ball, would you get a problem with this bunch?
If you increase the velocity of the ball, would you get a problem? Define problem.
That the ball is already too far, like it doesn't really intersect
Oh, good question. Yes, so potentially. I have made certain assumptions about the thickness of the ball, the velocity at which the ball is moving, and how frequently I'm firing the clock timer. I could absolutely come up with values whereby the ball could be here at one firing of the clock, and then here at one firing in the clock, and the paddle could have been here in the middle. So that would just be a mathematical mistake on my part, and something that I'd run the risk of if I had variable velocities. But all I'm doing with my velocity here is just inverting it, positive or negative. Good question. Other questions here? All right, so here is my artificial intelligence. If you really want to have basic AI in your game, really all I have to do is tell the paddle to move toward the ball along